morning, sir. My name is Chandra Singh and I am a mechanical engineer, final year student. Today I am here to give you a presentation on scramjet engines. So first let me walk you through the contents of this presentation. First we will look at introduction and need for a scramjet engine. Then we will take a look at a brief history of the scramjet engine. After that we will try to understand the working of a scramjet. Then we will understand a typical scramjet engine vehicle known as HyperX vehicle. After that we will look at applications and some challenges to the scramjet engine technology. And then we will conclude this presentation with some important remarks and references. So first let's try to understand the need for a scramjet engine. We all know rockets have been used to send satellites to the orbit for a long time. But there is a big disadvantage of rockets. Rockets carry their own liquid fuel and liquid oxygen with them. Oxygen is used for the combustion of fuel. Because of that, rockets can carry only 2 to 4% of their lift-off mass to orbit. This means if the rocket weighs 1000 kg on the Earth, only 40 kg of payload can be carried to the orbit. This is because the rest of the mass of rocket constitute liquid fuel and liquid oxygen. And in that liquid fuel and oxygen combination, 70% is oxygen. What if we could use oxygen from the atmosphere? We would not have to carry large oxygen tanks on the vehicle. That is the idea behind a different propulsion system called scramjet. Scramjet engines take oxygen from the atmosphere for the combustion of fuel, and therefore they don't have to carry large oxygen tanks with them. Therefore, the vehicle size becomes smaller, and since the size of the vehicle is smaller, it can go faster. Researchers predict a scramjet could reach 15 times the speed of sound, which is a very big number. And also, if we go through a commercial aircraft, it would take 18 hours to reach from Tokyo to New York City. But we can cover the same distance by scramjet engine in just 2 hours. Now let's look at a brief history for the scramjet engine. In the 1950s and 1960s, a variety of experimental scramjet engines were built and ground tested in the US and the UK. However, the first successful scramjet engine flight test was done in 2002 by Australia. And until today, there are only 4 countries that have demonstrated scramjet engine technology. Now you might wonder that how much difficult is this technology that only 4 countries could have mastered it. And in the experimental work for a scramjet engine started around 1950. But the first successful flight tests were done in 2002. So you might wonder, why did it take more than 40 years to realize this technology into application? We will address this question later in the challenges. Now let's try to understand the working and principle of the scramjet engine. But before trying to understand the principle of scramjet, we need to understand the principle of turbojets, because turbojets came much earlier than the scramjets, and it will help to understand the principle of scramjets. You can see in this picture down here, the picture shows Rolls-Royce RB211 Trent turbofan engine. This is one of the most common commercial aircraft engine used today. A turbojet engine is a gas turbine engine that works by compressing air with an inlet shown here and a compressor, mixing fuel with the compressed air, burning the mixture in the combustor, and then passing the hot high pressure air through the turbine and the nozzle. You can see that in this picture down here, this shows the side view of this turbofan engine shown in the previous picture. This is the side view of this turbofan engine. Now, there is a simple principle for every air breathing engine. This is same for every air breathing engine. This goes as follows. First, we need to increase the enthalpy of air by increasing its pressure with the help of compressor and its temperature by the combustion chamber. Only then we can add the fuel to the air. After the temperature and pressure of the air is high, that means the enthalpy of air is high, we can utilize this enthalpy and convert it into kinetic energy with the help of a nozzle. This is what we do in this turbojet engine. First, the air enters inside the intake through the fan and then goes into the compressor, where the pressure of the air increases, and we know if the pressure of the air increases, temperature increases simultaneously. After the compressor, the high pressure, high temperature air goes into the combustion chamber, where the fuel is added and ignited. So now the temperature increases further. Now we have a high enthalpy air after the combustion chamber. This enthalpy gets reduced by a small amount in the turbine. Now you might wonder why we have put turbine here. The turbine is put just so we can get work for the compressor. So turbine makes enough work to run the compressor, and after that we have enough enthalpy to convert into kinetic energy in the nozzle. And from the nozzle, high speed air comes out, and this makes the thrust for the engine to move forward. So this is the working of a typical turbojet engine. Now let's move from turbojet engine to ramjet engine. Ramjet engines does not have any moving part, unlike turbofan engine which we just saw. It is an open duct constituted of an inlet, shown here, combustion chamber and a nozzle. Now we just saw that a turbofan engine has a lot of moving parts, mainly 3 moving parts, including fan, a compressor and a turbine. All of 3 are missing in the ramjet engine. A ramjet engine is just an open duct. It doesn't have any moving part. It just has an inlet at the starting of this duct. Now you might wonder, if it doesn't have a compressor, then how is the air compressed before the fuel ignition? We all know that for the air to ignite, we need it to be at very high pressure and temperature, and the ramjet engine doesn't have a compressor. So how do we compress the air in a ramjet engine? We do it by ram effect. At flight numbers greater than 2, the incoming air, if captured and decelerated properly, can be compressed to required pressure. So air enters through the inlet at around Mach 2. It then decelerates, and with the decreasing velocity, pressure increases. With the increase in pressure, the pressure increases, and this is known as the ram effect. The decrease in velocity and the increase in pressure, this is known as the ram effect. After that, we put the fuel in the combustion chamber, ignite it, and then the air comes out of the nozzle at very high speed. Now if we don't need a compressor in the ramjet engine, we don't need a turbine, because the turbine was only placed in the turbojet engine so that we can generate work to run the compressor. And since we don't have a compressor in the ramjet engine, we don't need a turbine. However, a ramjet engine only functions if it is moving at Mach number of greater than 2. Now, the ram effect only works if the incoming air inside the engine is at Mach 2 or higher. So, the vehicle cannot take off or land by itself, because at that time the vehicle is not running at Mach 2 or higher. So what we do with ramjet engine, for any ramjet vehicle, ramjet engine would not be the only engine on board. For example, in the SR-71 Blackbird vehicle, we have turbojet engine as well as ramjet engine on board. The turbojet engine will be used for taking off, and when in the air the vehicle is cruising around Mach 2 or higher, turbojet engine is set off and ramjet engine starts working, and it works until the speed is below Mach 2, and when it has to land, the ramjet engine is again turned off and turbojet engine is used to land the vehicle. Now after understanding the ramjet, we now move to scramjet engines. At flight speed of more than Mach 5, the efficiency of ramjet engine decreases. Therefore we use scramjet engine over Mach 5. Now scramjet engines work in almost similar way to the ramjet engine. The only difference is that the combustion in the ramjet engine is done subsonically, while the combustion in the scramjet engine is done supersonically. You can see in the ramjet engine, air enters supersonically, that is at around Mach 2, and in the combustion chamber the flow speed is subsonic, that is less than the speed of sound. But in the scramjet engine, air enters at around Mach 5, and in the combustion chamber the airflow speed is less than the speed of in the scramjet engine the combustion takes place supersonically, while in the ramjet engine the combustion is subsonic. And this is why it is called a scramjet engine, because a ramjet engine in which the combustion is supersonic is called scramjet engine, that is supersonic combustion ramjet engine. Now we need to understand some more information about the scramjet engines. In scramjet engines, the engine is airframe integrated. Now what is an airframe integrated vehicle? You can see in this picture below, there is shown a vehicle. This is the complete vehicle, and these are the scramjet engine stacked one after the other, and one of these engine is shown in the expanded view here. Now we know what happens inside the engine. We have an inlet, a combustor and a nozzle, but what happens on the airframe? We need to understand that when the air strikes the front part of the vehicle or the aircraft, air is compressed, and this compressed air then goes into the scramjet engine, and after coming out of this scramjet engine, air again moves around the aircraft, around the airframe, and expands. So the engine, not only engine is doing the work of compression and expansion, but also the airframe is doing the work of compression and expansion. The front part or the forebody is compressing the air, and the aft body is expanding the air. So the airframe and the engine are integrated. Both of them are doing some work, and both are important. So this is known as airframe engine integrated. Another thing is, since the flow is supersonic, the flow is accompanied with shocks. We all know that whenever the vehicle speed is more than the speed of sound, shocks are generated. You can see that inside the engine there are shocks. Now this is a typical HyperX vehicle which is propelled by scramjet engine. Now you can see this is the top view of the HyperX vehicle. This is the front view and this is the side view. Now you can see the vehicle itself is not as large as it looks. The length of the vehicle is 3.7 meters, width is 1.5 meter, and height is 0.6 meters. And so this vehicle is much smaller than a conventional rocket. And you can see the aerodynamics of the HyperX vehicle. The front body, the full body of the vehicle, the air will come and strike the front part of the aircraft and it will get compressed. And then it will enter the scramjet engine where it will be ignited, and when it comes out of the nozzle, the air will again move along the airframe and will get expanded. So we can see that the airframe and the engine both are integrated, and this is very special quality of the Scramjet vehicles. Now after understanding the working of the Scramjet engine, we need to understand a few applications of the Scramjet. First one is space applications. We have already looked over the space applications. Scramjet can be an alternative to rockets. Rockets carry their own liquid oxygen with them, and therefore the payload they can carry is only 2 to 4% of their lift-off mass. However, Scramjet use atmospheric oxygen for combustion, which helps them to carry more payload. Therefore, Scramjets can help reduce the cost of satellite launching business to a very large extent. So with the help of Scramjet, we can reduce the cost of satellite launching, which is the most important aim for today's countries. Now, after looking at space applications, we will look at military applications. Now, the Scramjet engine is also employed in the missiles. Now, you might argue that we already have ballistic missiles, so why do we need Scramjet missiles? If you look closely, what a ballistic missile does is that it is powered in half of its flight, and for the rest of its flight, it is a stone. It is not powered for the rest of the flight. It goes as a stone. So for the rest of its flight, it cannot maneuver itself. It cannot enroute itself. But a Scramjet missile is powered through its entire flight, so we can maneuver it efficiently. So Scramjet missiles have better maneuverability and higher speed, which makes Scramjet missiles better than the ballistic missiles. Now we come to the civil applications. In around 1975, the first supersonic flight took place by the Russians, and 3 months after that, British and French developed another supersonic vehicle known as Concorde. These vehicles are not used now. Currently, the supersonic vehicles are not used for commercial aircrafts. But researchers predict that the Scramjet speed could reach 15 times the speed of sound. And an 18-hour trip to Tokyo from New York City becomes a 2-hour flight. Wouldn't it would be wonderful if we could travel between any two parts of the world within just 2 hours? Now, we will look at challenges to this Scramjet engine technology. Now, it's time to answer the question we put earlier. Why did it take more than 40 years to realize Scramjet engine technology? Scramjet engines are simple in the sense that it doesn't have any moving part. But applying Scramjet technology into reality is not that simple. We will address this in this section. So the first challenge to this Scramjet engine technology is the resonance time. Now, resonance time of a vehicle is the time for fuel air mixing and combustion in the combustion chamber. Now, we know that the airflow speed in the combustion chamber is more than Mach 2. So airflow is very high inside the combustion chamber, and to this high speed airflow we have to add fuel, mix it properly and ignite it and hold the flame. We have to do all these works in few milliseconds. So it becomes a very difficult task to mix fuel to this high speed air in just milliseconds. This is one of the biggest challenges to the Scramjet engines. Now comes the engine airframe integration. Boeing makes the airframe, Pratt and Whitney makes the engine. So the expertise of airframe making and the engine making are not in the same place, and that's okay for a commercial aircraft because the role of engine and airframe are separated. But you cannot do this separately for a Scramjet engine. The engine in the Scramjet vehicle is part of the airframe. It is because there is a big aerodynamic coupling between the two things. So we just saw that the airframe of the vehicle and the engine are integrated. They both have the job of compressing and expanding the air. So the testing of these Scramjet engines need the two areas to merge together. Now comes the drag. Now, if you want a reasonably long residence time inside the combustion chamber, you need to increase the length of the combustion chamber or the length of the vehicle. If you do that, if you increase the length of the vehicle, the drag on the vehicle increases. As the drag is not only on the airframe but also inside the engine, as the engine length is comparable to vehicle length. Now comes testing of the Scramjet engines. Building a wind tunnel for the Scramjet engines is very expensive. It is because to test any engine for supersonic speed, the power required for testing, even for a very small time, is very large. Now we have a lot of subsonic wind tunnels all over the world, but we have only a few supersonic wind tunnels all over the world. This is because for testing any vehicle for supersonic speed in a wind tunnel, we need a large amount of power even for a very small time. Now, since the testing is very expensive, we go for small scale testing. Now, even for small scale testing, we have another problem, which is scalability. How can you ensure that whatever you test for a small scale, you can apply the same thing to the large scale? This is the problem of scalability. Now you cannot be sure that the results for small scale will apply for the large scale for a circular intake, but it is easy for a rectangular intake. For example, if you test for a small rectangular intake, you can place rectangular intakes side by side and the results will be valid for a big or large rectangular intake. So we have reached the conclusion of the presentation. Today's satellites are launched into orbit by multi-stage satellite launch vehicles that can be used only once. These are known as expendable vehicles. If those vehicles are made reusable by Scramjet engine technology, the cost of launching satellites will further come down significantly. Thus, the further reusable launch vehicle concept, along with air-breathing propulsion, is an exciting candidate offering routine access to space at a far lower cost. There are a lot of challenges with the Scramjet engine technology, but its turn of application make it worth of more research. These are the references that I used for this presentation. Thank you. Have a good day.